Hello everyone. Welcome back to your own channel, Knowledge Base. If you're new here, don't forget to subscribe and hit the bell icon to stay updated with my latest programming tutorials. In today's video, we're going to explore a very important concept in Java: method overriding. If you want to master runtime polymorphism in Java, this topic is a must-know. So let's get started. Method overriding is a feature in Java that allows a subclass to provide a specific implementation of a method that is already defined in its parent class. In simple terms, when the same method name, return type, and parameters are used in a child class as in the parent class, the method in the child class overrides the one in the parent class. Why do we override methods? To achieve runtime polymorphism, which means Java will decide which method to call during execution based on the object type. Let's understand the syntax with a simple example. Here the show method is overridden in the child class. The @override annotation is optional, but it helps us avoid mistakes and makes the code more readable. Now, here's how runtime polymorphism works. Even though the reference type is parent, the object is of type child, so the overridden method in child class is executed. This is dynamic method dispatch in action. There are a few important rules to remember. Method name, return type, and parameters must be exactly the same. The access modifier in the child class must be the same or more visible. You cannot override private, static, or final methods. The overriding method must not throw new or broader checked exceptions. Let's take a look at a simple Java example that demonstrates method overriding clearly. Here we have a class animal with a method sound that prints a generic message. Then we have a class dog that extends animal and overrides the sound method with its own version. It prints dog barks. Now here's the interesting part. In the main method we are doing upcasting. That means we're referring to a dog object using an animal type reference. But when we call a.sound, Java will execute the overridden version from the dog class. This is called runtime polymorphism or dynamic method dispatch. And the output, as you can see, is dog barks. This simple example shows how the right method is chosen at runtime based on the object type, not the reference type. Now let's simplify method overriding even more with a real-world analogy. Think of a class vehicle. All vehicles can move, right? So we define a method move in the vehicle class. Now imagine we create two subclasses, car and bike. Each of them overrides the move method to define how they move. Even though all vehicles move, a bike moves differently than a general vehicle. So we override the move method inside the bike class to give a more specific behavior. This is method overriding in real life. A child class giving its own definition to a general action defined by the parent. It adds flexibility, reusability, and clarity to object-oriented programming in Java. Let's not confuse method overriding with method overloading. Overriding is redefining the method in the child class. Overloading means defining multiple methods in the same class with the same name but different parameters. Overriding is for runtime polymorphism, and overloading is for compile-time polymorphism. Imagine a class called vehicle that has a move method. Now a bike and car extend vehicle, but each has its own way of moving. So they override the move method with their own specific implementations. If you still want to call the parent class method from the child class, you can use the super keyword. Java allows overriding with covariant return types, which means the return type in the subclass can be a subclass of the return type in the superclass. Important note: static methods are not overridden. They are hidden. Private methods are not inherited, so can't be overridden. Final methods cannot be overridden at all. Trying to override any of these will result in a compile time error. So why do we use method overriding? To implement runtime polymorphism, to provide specific functionality to subclasses, to support the open/closed principle in OOP. Open for extension, closed for modification. To summarize, method overriding is a powerful feature in Java that helps you write flexible and reusable object-oriented code. Now let's wrap up today's session with some interesting practice questions to test your understanding of method overriding in Java. What happens if we change the return type in an overridden method? This is a very common question. If you change the return type of a method in the child class, it's only allowed when the return type is a subclass of the parent method's return type. This concept is called a covariant return type. But if the new return type is unrelated or more general, for example, changing string to object, then Java will throw a compile time error. So remember, return types must be compatible, and covariant types are allowed. Question 2. Can we override static or private methods? Why or why not? This is another favorite question in interviews. The answer is no. We cannot override static or private methods in Java. Why? Because private methods are not visible to subclasses. They are only accessible within the class in which they are defined. Static methods belong to the class, not to objects, so they are hidden, not overridden. If you write a static method with the same name in a child class, it's called method hiding, not overriding. So only non-static, non-private, non-final instance methods can be overridden. Question 3. Write a program to override a method that prints the area of a shape. Here's a simple example you can try at home. In this program, circle overrides the area method from the shape class. When we call s.area, the circle's version is executed. Again, an example of runtime polymorphism. Try modifying this example by adding other shapes like rectangle or triangle and overriding the area method in each. It's a great way to practice polymorphism and get comfortable with class hierarchies. Go ahead and write the code, experiment with return types, and try calling static methods to observe the behavior yourself. That's the best way to learn. If you have any doubts or want me to check your program, feel free to drop it in the comments below. I'll be happy to help. Let's demonstrate method overriding practically. If you liked this video, please give it a thumbs up, share it with your classmates, and don't forget to subscribe to Knowledge Base for more programming tutorials. In the next video, we'll explore another core Java concept. Until then, keep learning, keep coding. Subscribe to our channel to increase your knowledge with the Knowledge Base. Thank you.